Design and checks of horizontal bracing elements. Shear wall design. There are two different horizontal bracing elements to be considered during the design. First, the individual shear walls, and second, the building cores, consisting of a set of walls. This video will focus on the shear wall design. For more information about the building core, please refer to the next video of this series. Each shear wall has their own design element, which considers the forces of the respective walls. A cross-section is not required for the design step. The shear wall design is based on the integrated forces from the quad elements of the respective wall.
A simplified compression and tension method translates the resulting bending moments into a couple of forces, which get combined with the longitudinal normal forces.
The calculation is iterative and continues until an equilibrium is reached or the conditions cannot be met. It is possible to define the minimum and maximum edge zone lengths per wall, as well as the maximum reinforcement ratio for each edge zone type to control the iteration process. Using the SSD template for building design seismic analysis from within Revit, the shear wall design task is already present in our project tree. Otherwise, it can be found in the member design group of the Insert Task menu. We select the desired shear walls from the list of available walls on the left. The viewer to the right shows the associated building core and highlights the selected wall from the table to visually verify the selection. A good naming scheme for the walls helps navigating the list. In our case, let's perform the design for all walls except those associated with the topmost building core tier 1, because they are uninteresting to us. To do this, I type the building core's name in the text input field above and filter my table accordingly. Next, I finish my selection by choosing Deactivate All in the context menu of the first column. The load case table only shows load cases from the ULS fundamental and ULS seismic combination that store results for design elements. The default selection includes the relevant load cases for results such as normal forces, shear forces, and bending moments, and does not need to be adjusted. Other results, such as torsion or warping moments, are irrelevant for a wall-based approach and not supported by this task. We continue on the Design tab to look at the general design settings and define some geometrical boundary conditions for the individual walls. The viewer highlights a selected wall from the table below, additionally indicating the orientation according to the shown sketch. Edge zone A is always in the positive z direction of the local coordinate system for the wall. For easier understanding of the results, make sure your walls are modeled properly. The maximum reinforcement ratio limits are set uniformly for all walls within this task. They can be set separately for compression and tension edge zones. The edge zone length is increased incrementally between the minimum and the maximum values until an equilibrium is established and the resisting forces can withstand the acting forces. The minimum edge zone length is equal to the wall thickness, written in percentage and rounded to full integers. The maximum edge zone length is limited to half the wall length. Adjust this value to account for wall openings such as doors. On the final tab, we can adjust the level of detail for the created report. Descriptive texts explain what each level contains. By default, only the decisive load cases and respective forces or results are listed in each table, but this can be increased to include all result types. The report is created during calculation and can be accessed in the known ways, either through the ribbon bar on top or through the context menu. If shear walls are associated with a building core, the top-level structure of the report reflects that. All walls without a building core are grouped in the final chapter. Each chapter consists of the same subchapters, which can be modified by the settings in the Output tab. The Materials table lists the concrete and reinforcement used for the walls. If you are in a building core chapter, only one material each should be shown here. If several materials show up, you must have selected varying walls, which will lead to errors during the capacity check later on. The wall check explains the position of the edge zones according to the local coordinate system of the wall. The shear wall information lists the wall by level and wall ID and provides the reader with the dimensions and materials. If different materials are used in one building core, the culprit can be found here. The analyzed combination table lists the decisive load cases, as well as the total number of load cases that were analyzed. If more information is required, we can increase the output level for this section. For flexular design, aka bending around a strong axis, and shear design, two sets of tables each exist. The load case combination table shows the internal forces for the shear wall design, which represent the integrated forces of the individual walls. Therefore, it's mostly normal forces as well as bending and shear along the strong axis of the wall. Bending around the weak axis is comparatively small and being disregarded in this task. The next table contains the required reinforcement per wall per edge zone, indicating if it is compression or tension reinforcement with the footnotes. Another set of similar tables shows the results for the shear design.